Assalamu alaikum, my dear student. How are you? I hope all of you are fine by the grace of Almighty Allah. I am Muhammad Golam Mortuja and I am your physics teacher. And today I will discuss with you chapter 6, which is the effect of heat on matter. Okay? So let's start the class. Dear student, this is our today's first topic, and our first topic is expansion of solid. Okay, the length, area and volume of almost object will be increased if they are heated, and this is not difficult to understand the cause of heat and temperature if we explain it with the help of atomic model. And here we can imagine a solid as a collection of many molecules. We can compare the molecular force among with a spring, okay? And we have imagined a spring among molecules to show how molecules are arranged in a solid, as shown in the figure. And here you can see that the molecules are connected with each other by an imaginary spring, and this spring is a special type of spring, okay? When the solid is heated, its molecule will vibrate, and the higher temperature, the more molecules will be vibrate. That means if we increase the temperature, all the molecular vibration will be increased, okay? Since the molecules cannot come very close due to their special type of spring, but they can go far easily, okay? So all the molecules will establish a new equilibrium to move away slightly from one another, okay? And all the molecules, when they move away from one another, whole the solid seems to be like slightly expanded, okay? And this is the expansion of solid, okay? I hope you understand what is the relation between temperature and the expansion of a solid. Dear student, this is our second topic, and here you can see that the length, breadth and the height of a solid are expanded equally in three directions by application of heat, and in this figure you can see that, okay? That means if we apply heat, then the length of an object will be increased, or the area of an object will be increased, or the volume of an object will be increased, okay? To analyze this expansion, three quantities named coefficient of linear expansion, which will be applied to find out the linear expansion of a solid, the coefficient of area expansion, which will be applied to find out the area expansion of a solid, and number 3, the coefficient of volume, which will be applied to find out the volume expansion of a solid, okay? And now I will discuss with you what is the linear expansion of solid, or what is the area expansion of solid, and what is the volume expansion of a solid, okay? Dear student, our next topic is the linear expansion of a solid, okay? And here you can see that if the length of an object is L1, that means the length of an object is L1, okay? At the temperature T1, that means when the initial temperature is T1, at that time the length is L1, and then the length is increased to L2 after increasing the temperature to T2. That means when the temperature will increase to T2, at that time the length of this object will be increased by L2, okay? Then the coefficient of linear expansion alpha is here alpha equals to L2 minus L1 divided by L1 into T2 minus T1. Dear student, do you know what is the meaning of coefficient of linear expansion? The meaning of the coefficient of linear expansion is the ratio increase in length with the original length for 1 Kelvin rise in temperature is called the coefficient of linear expansion. Okay, and here you can see that the equation of the coefficient of linear expansion, and by using that equation, if I want to find out the increased length, then I have to do that. L2 minus L1 equals to alpha L1 T2 minus T1. And if I want to find out the increased length, then L2 will be L1 plus alpha L1 T2 minus T1. So dear student, this is the equation. By using this equation, we can find out the increased length of any object. Okay? And our next topic is the area expansion of solids. Okay? If the area of an object is A1 at temperature T1, okay, that means if at T1 temperature the initial area of a solid is A1, okay, and increasing the temperature T2 if the area is increased to A2. That means if we increase the temperature from T1 to T2, then the area of that object will be increased from A1 to A2, and in this figure you can see that. Okay, then the coefficient of area expansion beta is beta equals to A2 minus A1 divided by A1 into T2 minus T1. Okay, so dear student, do you know what is the coefficient of area expansion? The ratio increase in area with the origin area for 1 Kelvin rise in temperature is called the coefficient of area expansion. Okay, so this is the formula of coefficient of area expansion. Okay, and by using this equation or formula, we can find out the increased area. Okay, so if we want to find out the increased area A2, then I have to do that. Okay, so A2 minus A1 and the cross multiplication of beta A1 T2 minus T1. So I want to find out the expanded area. Okay, so A2 equals to A1 plus beta A1 T2 minus T1. So my dear student, by using that equation, we can find out the increased area of any solids. Okay, I hope you understand. Dear student, our next topic is the volume expansion of solids. Okay, and here you can see that if the volume of an object is V1 at temperature T1, that means at the initial temperature the volume of an object is V1. Okay, so increasing the temperature T2 if the volume is increased to V2. That means if we apply the heat and then the temperature is T2, after that the volume will be increased and the increased volume is V2. Okay, so the coefficient of expansion of volume gamma is V2 minus V1 divided by V1 into T2 minus T1. Okay. And dear student, do you know what is the coefficient of volume expansion? Ratio increase in volume with the origin volume for 1 Kelvin rise in temperature is called the coefficient of volume expansion. Okay, and this is the formula of the coefficient of volume expansion. Okay, dear student, by using that formula or equation, we can easily find out the expanded volume. Okay, so if I want to find out the expanded volume, then V2 minus V1 equals to gamma V1 into T2 minus T1. Okay, then V2 equals to V1 plus gamma V1 T2 minus T1. So, dear student, by using that equation, we can easily find out the expanded volume for any solid. Okay? Dear student, our next topic is the unit of these three quantities. That means, what is the unit of the coefficient of linear expansion, the coefficient of area expansion, and the coefficient of volume expansion. Okay, so the coefficient of linear expansion is alpha, the coefficient of area expansion is beta, and the coefficient of volume expansion is gamma. So the unit of these three quantities is per Kelvin. Okay, now I will discuss with you the dimension of coefficient of linear expansion alpha and the coefficient of area expansion beta and the coefficient of volume expansion gamma is T inverse. Okay, I hope you understand what is the unit and the dimension of these three quantities. Dear student, now our next topic is the relation among these three quantities. That means now I will discuss with you what is the relation among the coefficient of linear expansion, the coefficient of area expansion, and the coefficient of volume expansion. Okay, so at first I will show you what is the relation between the coefficient of linear expansion and the coefficient of area expansion. Okay, so the relation between three quantities are beta equals to 2 alpha. Okay, the coefficient of area expansion of a solid is the 2 times of the coefficient of linear expansion for the same solid. Okay, and now I will show you what is the relation between the coefficient of linear expansion and the coefficient of volume expansion. Okay, so the relation between these two quantities are gamma equals to 3 alpha. That means the coefficient of volume expansion of a solid is 3 times of the coefficient of linear expansion of the same solid. Okay, and if I want to make the relation among these three quantities, okay, that means if I want to establish a relation with the coefficient of linear expansion and the coefficient of area expansion and the coefficient of volume expansion, then the equation will be look like that. 2 gamma equals to 3 beta equals to 6 alpha. So, dear student, this is the equation or this is the relation among these three quantities. Okay. My dear student, now I will solve a mathematical problem from this chapter. Okay. And here you can see that the question is the length of a steel rod is 10 meter at 20 degrees Celsius temperature. If its length becomes 10.0167 meter at 120 degrees Celsius temperature, then determine the coefficient of linear expansion of steel. Okay? So here you can see that the given values are the initial length L1 equals to 10 meter. Okay? And the final length, that means after increasing the temperature, the final length of this steel rod L2 is 10.0167 meter. Okay, and the initial temperature is 20 degrees Celsius. That means T1 equals to 20 degrees Celsius. Okay, and here I can convert this degree Celsius to Kelvin scale. Okay, so if I want to convert, then I have to add 273. Okay, so 293 Kelvin, and the final temperature T2 is 120 degrees Celsius. And here I can also convert this degree Celsius to Kelvin scale. Okay, so 120 to 273 Kelvin equals to 393 Kelvin. Okay, and I have to find out the coefficient of linear expansion alpha equals to what? And my dear student, we know that what is the formula of the coefficient of linear expansion. Okay, and we know that the coefficient of linear expansion alpha is L2 minus L1 divided by L1 into T2 minus T1. So now I have to put all of this value in this equation. Okay, and here you can see that L2 is 10.0167 minus L1 equals to 10, and L1 equals to 10, and T2 equals to 393 minus T1 equals to 293. If I put all of this value in my calculator, then I will get alpha equals to 16.7 into 10 to the power minus 6 per Kelvin. Okay, so I hope you understand how can we find the coefficient of linear expansion by using all of this given value. Student, our next mathematical problem is here, and here you can see that the initial length of wire is 2 meter. The length increased by 0.1 meter for the rise of temperature from 30 degree to 55 degree Celsius. Okay, so find out the coefficient of volume expansion of wire. Okay, so here the given values are the initial length. Here you can see that L1 equals to 2 meter. Okay, and the increased length, that means del L equals to L2 minus L1 equals to 0.1 meter, and the initial temperature T1 equals to 30 degree Celsius, or 30 plus 273 Kelvin, 303 Kelvin, and the final temperature here you can see that 55 degrees Celsius. Okay, that means 55 plus 273 Kelvin equals to 328 Kelvin, and I have to find out the coefficient of volume expansion gamma equals to what? But my dear student, here you can see that all the values are, here you can see that the length, increased length, okay. So by using the initial length, increased length, initial temperature and final temperature, at first I have to find out the coefficient of linear expansion, and after that we know that there is a relation between coefficient of volume expansion and the coefficient of linear expansion. So through the coefficient of linear expansion we can easily find out the coefficient of volume expansion, okay. So dear student, at first I have to find out the coefficient of linear expansion, and I know that the coefficient of linear expansion alpha equals to L2 minus L1 divided by L1 into T2 minus T1. So if I put all of this value in this equation, then it looks like that L2 minus L1, that means the increased length, okay, increased length will be 0.1 and L1 equals to 2 and T2 equals to 328 minus T1 equals to here 303, okay. So if I put all of this value in my calculator, then I will get the value will be 0.002 per Kelvin, okay. So this is the value of the coefficient of linear expansion. And my dear student, I know that the coefficient of volume expansion gamma equals to 3 alpha. So gamma equals to 3 into 0.002 equals to 0.006 per Kelvin. So I hope you understand, my dear student, how can we find out the coefficient of volume expansion for this steel rod by using all of these values, okay. Now I will discuss two questions related with this topic, okay. So our first question is, why gap is kept at the joining point of two rails at a rail line? Do you know why gap is kept at the joining point of a rails at the rail line? The rail expand due to the heat of sun, okay, or due to the heat produced by friction between wheels and rail while the train runs, okay. And for this expansion, sufficient space is kept between two rails so that the rail line does not bend due to this expansion. And so to avoid that kind of accident or that kind of situation, we need to keep a gap at the joining point of rails at the rail line, okay. I hope you understand. And our second question is, why does a thick walled glass bottle crack when hot water is poured into it? Do you know why that is happened? Okay, let me explain it. Do you know why that happened? So let me explain it. If hot water is poured into a glass, it breaks. As hot water is poured, due to the heat, the inner side of a glass expands. But as glass is heat non-conductor, the outer side remains same. So though the inner side expands and outer side does not expand, and this expansion force causes the glass to break, okay. And that's why a thick walled glass bottle crack when hot water is poured into it. Okay, but if the glass is thinning, the heat can easily get out, so expansion occurs everywhere easily, and that time the glass will not break. I hope you understand these two questions. Dear student, I hope you have enjoyed the class very much and you have learned all of the things which I have discussed in this class. Inshallah, see you again. Assalamu alaikum, my dear student.